In this video, we're going to take a look at applications that involve an irregular system of three equations. And remember, with our applications, the main thing is just to sort through the information first to figure out what it is that you don't know, and then write equations based on those variables. So looking at this example here, we have a friend emails you results of a swim meet. Maybe you're writing an article about it. And from the email, you see that there's a combined total of 53 points scored by all of the finishers during the meet. And first place earns you 3 points, second place 2 points, third place 1 point. Out of all the finishers, there were 17 who finished in either first or second place. There were also 5 more first place finishers than third place finishers. So the question at the end is how many swimmers finished in each place? And that is the hint as to what it is we're looking for and how we'll construct our variables. So the first thing we need to know is what letters we're going to use. And the question saying how many swimmers in each place. We've talked about 3 different spots for finishing, either first, second, or third place. So we're going to need 3 variables. You can either use letters to represent first and second and third, such as F, S, and T, or if you just want to stick with X, Y, and Z that we're comfortable with, that's also okay. So here, I'll start off with X equals and Y equals and Z equals. And let's just go in order here. X will be the number of first place finishers. Okay, and the Y will be same thing. We're going to use that as the number of second place finishers. So the number of second place, we want to be a little bit specific here as to what we're doing, how we define our variables. We don't want to just put second place. We are talking about how many finished in second place. And Z, the same idea, the number of third place finishers. Okay, so we have our 3 variables, x, y, and z. And now what we're going to do is we're going to write 3 equations because the general rule is if you have 3 unknown values, you need 3 equations to solve for them. That holds true throughout. If we have 2 things we don't know, we need 2 equations. If we have 10 things we don't know, we need 10 equations. But in this case, we need 3 equations because we have 3 different variables. So sometimes an easy place to start is go back through the situation and see if there are any totals that you can apply. So this first equation, this first sentence, we don't really need. That's just telling us what's going on about the swim meet. But here we see that we have an email that had a combined total of 53 points. That is a total amount of points. And so we can write an equation using this 53 by just putting equals 53 to start out. And once you use a value, you do not reuse it. So a total of 53 points were earned by all finishers. So how do we get those points? Well, we look here, keeping on the idea of point values. First place earns 3 points, second place earns 2 points, third place will earn us 1 point. And so going along that, to show 3 points for first place, we use 3 as the coefficient. So 3x, 3 points for first place, with 2 points for second place and 1 point for third place. We don't have to put the 1, but if we want to put it there so that we see where it came from up here in the story, that's okay. And again, we won't reuse any of that information. So we need to come up with a couple more equations. We do see the next sentence here says, out of all the finishers, there were 17 who finished in either first or second place. So we're not talking about third place finishers here. Between first place and second place, there were 17 total finishers. So just like before, we'll use letters to represent first place and second place. So that is x plus y equals, and in total there were 17 that were in that category of first and second. And we are now finished with this. One more equation coming from our next sentence that says there were 5 more first place finishers than third place. And realize that means there were more people in first place than in third. So when you think of this 5 more, and you know that means to add 5, be careful where you put it. We use X to represent first place, but on the other side, I'm going to have Z for third place, and that is where I'll put the +5, because adding 5 with Z gives me a bigger value than Z. And remember, we're supposed to have more first place finishers than third place finishers. Okay, so here are my 3 equations. We want to solve for all 3 variables. We've already practiced this a little bit. Earlier in the first video, we talked about substituting in for X. And we can replace X with a Z plus 5 anywhere we want to. It might take a little more work this time because this first equation has all 3 variables in it. So another option to this is still use elimination. So I'm going to rewrite this last equation by subtracting Z on both sides. We can set up this equation like the other ones, where the variables are on the left side and our constant values are on the right. So we have, in this scenario, X minus Z equals 5. Okay, so there's our equations. Now what we want to do is we want to solve. And the key to solving these systems that have 3 variables is find a way to get rid of one of those variables so that you can continue through methods that we've practiced in the past. So in this case, here's my thought. I have these equations here. This last equation has the letters X and Z. And if I can take these top 2 equations and get rid of the letter Y, then I'll have a new equation that also has the letters X and Z corresponding to this, which is going to allow us to continue. So we need 2 equations with the same 2 letters. Let's keep this one the same. It already has 2 letters, but let's make another equation that has these same letters, X and Z. So here's what I'll do. I'm going to take our first and second equation up here. And in this first step, I'll write those equations down. 3x plus 2y plus z, or 1z, equals 53. And we have an x plus y equals 17. Now notice here, I'm going to line up common pieces, common terms. I'll put x below x and y below y. Equals will still line up, and these constant values still need to line up. And I'm going to cancel the variable y because this other equation we have does not include the variable y. So if we want to cancel y, we do need to multiply here. And if we multiply this equation by -2, we should be fine. So let's write what this is going to say. It's going to give us a -2x minus 2y equals -34 is what we get from -2 times 17. So we multiply by -2. If we leave the top equation the same, hopefully you notice that here we have a 3x and here we have a plus 2y, which cancels with the minus 2y below it. So we have 3x plus 2y, we had a plus 1z, which again is just z, equals 53. Now if we combine these equations, 3x plus -2x is 1x. The y's cancel. We have a plus z, plus 1z, equals, that is 19. Okay, so here's what we did. We made an equation that uses the letters x and z that we can now pair with this other equation that we have that uses the letters x and z. So for my next step then, I'm going to bring these 2 equations together that we've created. So we have x minus z equals 5 from up above. And we have x plus z equals 19. And the good news is in this scenario, we don't have to do much to eliminate because the z's are already going to cancel when we combine our equations. So no need to multiply here. Let's combine our equations. Let's be careful. This is a 1x plus a 1x. That is 2x. The z's are now gone. And then we have 5 plus 19. That is 24. Okay, so we have 2x equals 24. As we start getting rid of more and more letters, as we see here, we can finally solve for our first variable by dividing by 2, and we get x is equal to 12. And so that's the beauty of elimination. You just keep getting rid of more and more pieces until you finally start getting solutions, and that's what we've done here. We have an answer of 12 for x. Okay. So what we need to do now is we need to solve for our other values. So now that you know x is 12, you can go ahead and start using that in any equation that has the letter x, but that also allows you to solve for something for another variable. So for example, here, we have this equation that says x plus y equals 17. If we replace this x with a 12, then that's going to allow us to solve for y. So let me take, for my third step here, let me take this equation, x plus y equals 17. But let me replace that x with a value of 12. So we have 12 plus y equals 17. And now we can start solving. This is just 12 in the beginning, so we can cancel that through subtraction. And we get y is equal to 5. So once you start getting solutions, things tend to go very quickly. Now we have y equals 5. We still need to know that what z is equal to, okay? And so we have options. We can either go find an equation to substitute this 5 in for y, or you see that there's this equation right here that says x plus z equals 19. And if we just use our x value again, remember, we still know that x is equal to 12, we can use that here, and that's going to allow us to solve for our last variable. So let's replace this x with a 12. We have 12 plus z equals 19. Subtract 12 like we did earlier, and we get z is equal to 7. Okay, and now we have our three values that we needed. We do not write an ordered triple here because this is an application. So this is some scenario that we're talking about, not just some three equations that we're working with. These equations represented things we knew about the swim meet. And so it's nice to define our variables in a way that we understand. I know that x is first place finishers, y is second place finishers, and z is third place finishers. So when we come down here to interpret our result, that's what we'll do. We'll state these things in words that pertain to our scenario. So to answer the question, we simply include this information. There were 12 first place, comma, 5 second place, and 7 third place finishers. Okay, and that sums up exactly what's going on in this scenario. Now, one other thing I encourage is that you make sure your results to an application make sense. Do these numbers make sense in terms of these races that we're having in the swim meet? And you might say no. Why would there be so many more first place finishers than second place finishers? And why are there more third place finishers than second place finishers? How's that possible? Well, if you consider ties to be interpreted, if two people tie for first, which is very unlikely in a swim race, but it could happen. If people tie for first place, they're both considered the winners of that race. So maybe in that case, we say in those races we say there are two first place finishers and no second place finisher in that scenario. So These are the results that we get. These are the correct results. Luckily, we did that correctly. And all of that came through solving a system that we created on our own from the sentences provided in the story.